Okay, so now let's understand how will we find the focal length of the concave lens using the lens formula, which is 1 upon f, that is equal to 1 upon v minus 1 upon u. So this is our object pin, guys. This is object pin, and this is our convex lens, and this is our image pin, right? Why do we use image pin? That I will let you know shortly. Okay, so below I have used a ray diagram to explain you what are we doing over here. So over here we have an object pin, right? Now these two rays are going to come out from the object pin. They will pass through the convex lens. Since convex lens is a converging lens, these two rays will finally meet over here. So you will get a real and inverted image of this object pin. So just let me write down image of object pin. And since it is in the air, right, we can see it through the lens from this side if you place your eye. But how will you measure this image distance? That's why we have placed an image pin at the bottom. You can see that this is your image pin. This at the top is an image pin, and we have placed it exactly below the image pin, and then we have removed the parallax error. If you do so, then the distance from the lens to the image of the object pin and the distance from the lens to the image pin will be the same. Okay, now once we have done that, right, we have already noted the position. This was at 0 centimeter mark. I'm talking about the object pin. Then the convex lens was at 36 centimeter mark, and this was at 70.5 centimeter mark, the image pin. Correct? Now what is going to happen, guys, if we place a concave lens in between like this? Correct. Now the concave lens is a converging lens. So what's going to happen? That these two rays will be further diverged and they will meet somewhere behind they were actually meeting. So since these two rays were diverging, let me remove this eye part. Now it is not required. So let me remove this part now. Yeah. So the diverging lens is going to further diverge the rays beyond this point, and finally they are going to meet over here. Correct. Now in this case, what is the object for the concave lens? For the concave lens, these two incident rays, red color incident rays, appear to be coming from this image pin. It appears to be coming from this image pin. So this image pin behaves like an object for whom? For the concave lens. And the distance, and we have placed this concave lens at 64 centimeter mark. So that means this distance will be referred as u. It's a virtual object, guys. Virtual object are, the rays, they appear to be coming from the virtual object. They don't actually come from the virtual object, and these two are converging rays. So converging rays, when extended behind, you will get the virtual object. So this image pin itself will behave as a virtual object for the concave lens, and finally you will get a image which is at this particular point. I'm going to call this point as O. Correct. And once again I will have to move because I will get again the final image shifted behind. Now guys, you would be astonished a little bit that this is again a real image. Why? Because the rays are actually meeting. You see that these two black color rays are actually meeting. So in case of concave lens, if the object is virtual, image can be real, right? So now again, to find the distance between the final image and the concave lens, this distance v, again I have to shift this image pin backwards and I have to remove the parallax error. And this is what I have done previously. And this is what I'm going to do it right now also. So that means I'm going to remove parallax error and I'm going to place this image pin over here, and this gap this distance which I received was 76.5 centimeter. So the distance from here to here will be v. So let me write down this formula again. 1 upon f is 1 upon v minus 1 upon u. Now u in this case is the distance between 64 and 75, sorry, 70.5. So it is plus 6.5 centimeters. And for the virtual object, u is positive. Now, what is v? The final image for the concave lens, that is the gap between 64 and 76.5. So that is plus 12.5 centimeters. Since it is a real image, it is formed behind the lens. So this is real image. And I'm going to use these two numbers to find f. Your f must come negative, guys. So 1 upon f is 1 upon 12.5 minus 1 upon 6.5. Now, if I do the calculation, this is 6.5 minus 12.5 upon 12.5 multiplied by 6.5. So if I solve this, I was getting this answer as minus negative of 13.5 centimeters. Right? If you solve this, you will get your answer. The actual focal length was at 15 centimeters. But now, due to some of the errors, and errors are always allowed in the experiment, so I got this answer. And I hope that you have enjoyed this experiment. Please do ask your doubts if you have in the comment section. Thank you very much for watching the video.